dental caries has afflicted man throughout the ages. A compassionate priest-physician of 16th century England once wrote, "A tooth is a sensible bone, the which being in a living man's head hath feeling, and so hath none other bone in a man's body, and therefore the toothache is an extreme pain." With the passage of time, the prevalence of caries has reached pandemic proportions. In many countries, the number of new lesions per year far exceeds the total being treated. Each year, 12 to 16 tons of teeth are extracted, and our nation pays $2 billion to have the ravages of dental caries repaired. Widespread dental deficiencies surfaced during World War I. Recent estimates show that every 1,000 inductees into military service require 6,000 fillings, 1,000 extractions, 400 bridges, 275 crowns, 175 partial dentures, and 12 full dentures.
Clearly, there is a need for the development of an effective means of preventing dental caries which could be readily available to the general public. Research supported by the National Caries Program of the National Institute of Dental Research is committed to this objective. The research is aimed at combating the microbial agent, increasing the host resistance, and altering the dietary environment. I am Dr. William Bowen of the National Caries Program, and it is my pleasure to report to you briefly on some of the approaches to this universal problem. The major approach to date has been to strengthen the resistance of the tooth through fluoride administered in the drinking water. The use of a fluoride gel has also proved to be most effective, but other vehicles are also under study. For example, the combined use of a daily fluoride tablet, a weekly rinse with a fluoride mouthwash, and the use of a fluoride toothpaste is now being tested. An adhesive sealant which seals pits and fissures is highly promising, but is being subjected to further research. At the same time we are moving in these directions, we must also pursue more elusive possibilities in a fundamental way. Vaccination is such a possibility. It has proved to be a practical means of controlling many diseases and has led to the virtual elimination of many others. The concept of adopting an immunological approach to the control of dental caries may appear far-fetched, particularly when it is realized that the tissue affected, namely enamel, is not in direct contact with the immunological system of the body. Since the tooth is bathed in saliva and not blood, it would appear more productive to focus attempts to immunize on the salivary system. The quest for a caries vaccine goes back many years. On the assumption that lactobacilli are the causative microorganisms of dental caries, previous investigators have prepared a vaccine of various strains of Lactobacillus acidophilus and injected the preparation into humans. A reduction in the numbers of lactobacilli in saliva was observed. However, no information was provided on the effect the vaccine had on the incidence of dental caries. Epidemiological investigations carried out in England and in the United States have indicated that a relationship exists between the prevalence of dental caries and the levels of immunoglobulins and antibodies in saliva. It was perhaps prophetic of G.V. Black, who wrote in 1908, "The logical inference is that the cause of the differences in the liability of individuals to caries of the teeth is something in the constitution, operating through the oral fluids and acting upon the active cause of caries, hindering or intensifying its effect." To recapitulate, the essential factors in the pathogenesis of dental caries: a susceptible tooth must first be colonized by cariogenic microorganisms. The initial stage in plaque formation is the absorption of protein from saliva to form a pellicle on the surface of the tooth. Microorganisms, and particularly Streptococcus mutans and Streptococcus sanguineus, attach themselves through specific receptor sites onto this layer of pellicle. Plaque increases in bulk through the microorganisms multiplying and also by the formation of sticky dextran and levain from sucrose. A vaccine against dental decay may prevent dental caries through several possible mechanisms. Following vaccination, antibody may enter the mouth through salivary glands and through the gingival crevice. The antibody could combine with the microorganisms, block their receptor sites, and prevent them colonizing the tooth surface. Antibody may also prevent the formation of dextran and levain by covering the enzyme sites on the bacteria, thereby preventing interaction with sucrose. A third possibility is that microorganisms covered by a layer of antibody are very susceptible to phagocytosis. Significant numbers of polymorphonuclear leukocytes are frequently found in saliva and could lead to a reduction in the numbers of bacteria in the mouth. Rodents have been successfully vaccinated against caries using both dextran sucrase and levain sucrase. However, the primate would seem to offer several advantages as an experimental animal for this kind of study. It has a dentition similar to that of man. It also has an oral flora, many of whose components are also found in the human mouth. The monkey can be subjected to procedures which are difficult to carry out in the rodent. The primate can be fed a human-type diet and develops carious lesions which clinically, radiographically, and histologically cannot be distinguished from those which occur in humans. Further, antibodies produced against human immunoglobulins even react with those from the primate. In the course of my work in London, we did reduce the number and the severity of decay lesions in monkeys by intravenous injections of live Streptococcus mutans. Characteristic colonies are shown here, surrounded by sticky dextran and levain. However, it is probable that effective results can be obtained from using the secretory as well as the serum system. This approach has been made at the State University of New York at Buffalo by grantees supported in part by the National Institute of Dental Research. We are also working in this area at our newly established facilities in the NIH complex. At Buffalo, injections of killed Streptococcus mutans were made into the ducts of the parotid salivary gland of anesthetized monkeys. The vaccine stimulated production of salivary antibodies against the decay-causing Streptococcus mutans and thereby dramatically reduced their numbers. The antibodies are revealed using fluorescent techniques. Although this achievement is encouraging, more work remains to be done before a vaccine can be tested in man. First, it must be proven that a vaccine against only one organism will decrease decay significantly, and that it is, of course, safe. Because injections into the salivary glands and ducts are not without pain and risk of infection, we must also look for other routes of administration.